Hi everyone, myself Bidyutlata Sahoo, working as an assistant professor in the Department of CAC, Artificial Intelligence and Machine Learning at Institute of Aeronautical Engineering, Hyderabad. Today I am going to discuss about few definitions and terminology on the topic problem reduction and game playing, which is the third module on the course Applied Artificial Intelligence. Already I have discussed in my previous two videos for the module 1 and for the module 2, like for beyond classical search and the knowledge representation chapters. I have discussed around 40 definitions and terminology, and I have discussed why the definition and terminologies are important for the students, because students, they have to first remember all the terminologies. They should be acquainted with all the technical terms related to artificial intelligence. Then it would be easy for them to understand the subject. Anyways, so let me start. Actually, for this particular topic, there are two course outcomes as per our syllabus. So one is CO2 and CO3. CO2 says that after the completion of this particular course, students can apply the bounded look-ahead strategies to predict the future states for decision-making in gaming applications. And CO3 says that after the completion of this course, students can examine the situation that are inherently fuzzy while designing logical systems to deal with ambiguous data. Actually, this particular module is related to game playing and fuzzy logic. So, related to these two topics, I will discuss few definitions and terminologies. This is the first term I want to discuss over here. What is the meaning of problem reduction? In the field of artificial intelligence, problem reduction means breaking down a complex problem into smaller and manageable sub-problems, and each sub-problem is solved independently and their solutions are combined to address the original problem. The meaning of the statement is, if the main problem is a big problem, the big problem will be divided into number of sub-problems. This is the sub-problem 1, sub-problem 2, sub-problem 3 and sub-problem 4, and each sub-problem will be solved individually. They produces their output, and all the output will be combined together to form the final output. This is the initial problem. Initial problem will be divided into number of sub-problems, and each sub-problems will be solved independently. They will generate their outputs, and all the outputs gets combined together to find out the final solution for this particular problem. That terminology is called as problem reduction. Especially this type of techniques are used in the area of game playing in artificial intelligence. The next term is the search tree. Search tree represents all possible states and moves in a problem or game. Here, nodes depicts the states while edges indicates the transition between the states. Why it is called as a search tree? First of all, this search tree technique is used in game playing process or game playing techniques in artificial intelligence. So, to play the game by the machine or by the artificial intelligence software, the whole game can be represented in the form of a tree, and the tree consists of various steps or various states. The states are represented with the help of node, and each node, and it would be in the form of tree format. Again, from this state another two children would be there. So like this, the tree can be represented, and each node, the circle is called as the node. Node represents the state at a particular moment of time, and the edges represent the transition between from one state to another state. That is called as a search tree. So using the search tree, the algorithm, different types of algorithms can be performed in artificial intelligence, like depth first search or breadth first search or A-star algorithm or AO-star algorithm. So it would be very easy for the AI machine or the AI application to navigate starting from the start node to the goal node. I mean, to find out the final solution through the search tree. The next term is bounded look-ahead strategy. why the term is called as bounded look ahead strategy. Bounded means something is fixed. So this is a strategy. Again, this type of strategy is used in the area of game playing by artificial intelligence. It limits the depth of the search tree explored to make the decisions within a fixed computational budget, and it balances the computational feasibility and decision quality. That means if you what this particular terminology says, bounded look ahead strategy. Suppose the search space, the game requires more number of states or more number of transitions from one state to another state. In that case, all the transitions and all the states, searching of all the transitions and all the states would be difficult. If the AI software application performs or AI agent performs all the searching of all the states at a time, then it may take lots of time and the output may not be generated. So instead of to avoid that computational complexity or the time, so this method, this bounded look ahead strategy is implemented by the AI agent, so that it will search up to a particular depth and it will try to find out all possible solution up to particular depth. If it is found, then it is well and good. Otherwise, after finding the solution up to a particular depth, then it will move forward to find out the final solution. Now you can take the example of the chess game. So chess game, for each movement there would be number of movements. So by the AI agent, whenever the system plays or the AI agent plays this particular type of game, it will not search the whole search space. It will fix some certain depth. Maybe the depth would be 2 or 3. Up to that depth, all the searching will be performed. And based what would be the final output? What is the optimal value within that depth? Based on that optimal value, means best possible path, if it is found within that particular depth, then that will be followed to find out the final solution. So that terminology is called as bounded look ahead strategy, which is used in game playing by the artificial intelligence. The next terminology is evaluation function. An evaluation function, it is a tool in artificial intelligence which estimates the desirability of a game state when the end is not yet reached. It helps in decision making during the intermediate stages of a game. Normally, the evaluation function, it is nothing but a function, or it is a tool, we can say, which assigns some values or assigns some scores to a particular state, so that it can the AI agent can determine whether that state is a good state or bad state. If it is a good state, it is well and good. If it is not a feasible state, it will try to find out the alternate solution. So that is called as the evaluation function. Like whenever we are playing the chess game or tic-tac-toe game, so it assigns some scores to each particular state. Based upon the score value, then the agent will decide whether to move left side or right side or up or down or diagonal. So that kind of decision can be taken. So that is called as evaluation function. The next one is Minimax algorithm. This is a very important algorithm which is used in the case of game playing by the artificial intelligence, and it is a strategy for minimizing the maximum possible loss in adversarial games. It assumes the opponent plays optimally to counteract the player's move. First of all, this Minimax algorithm, as the name it implies, first of all, it is applied for two-player game. One is min, another one is max. And it assumes, this particular algorithm assumes that both the players plays optimally. That means one player will try to maximize its advantage, and the opponent player will try to minimize the maximizer's advantage. So both the player will play optimally, and there are two threshold values are considered to solve this type of problem. One is alpha, another one is beta. So alpha is the threshold value for the max player. This is the threshold value for the max player, and beta is the threshold value for the min player. So using these two threshold values, the Minimax algorithm can be solved in game playing. Especially it is used to solve the chess game or the tic-tac-toe game when it is played by the AI agent. Next terminology is the alpha-beta pruning. This is alpha beta pruning is the advanced concept of Minimax algorithm. Actually, the problem with the Minimax algorithm, though Minimax algorithm is used in game playing and it is used to solve all game playing problems, but it takes lots of time because it searches all the nodes in the search space. So to avoid that problem, this alpha beta pruning method is used, which optimizes the Minimax algorithm by skipping the unnecessary evaluations in the search tree. It reduces the computational time without affecting the final decision. That means here what happens, how alpha beta pruning, first of all, it is a technique which can minimize or which can optimize the optimize the time or in the form of cost of the Minimax algorithm. How it can optimize? By cutting the edges or by cutting the leaves which are unnecessary, which are unnecessarily present inside the tree, and if we cut that part of the tree which does not affect to the affect to take the final decision, those kind of things or those kind of branches or trees will be pruned from the tree. That is why it is called as alpha beta pruning. And why the name is called as alpha beta pruning here? The two threshold values are used. One is alpha, as I told in the Minimax algorithm, the same alpha which is a threshold value used for max, and this value is minus infinity, and beta is the threshold value for min, whose value is plus infinity. So using these two values, the problem can be solved and the unnecessary leaves or unnecessary branches will be cut or will be pruned from the tree to find out the final solution, which does not have any impact to take the final goal or final result. That is why it is called as alpha beta pruning. And this type of algorithms are used in search space, even in the game playing techniques. The next term is heuristic function. Heuristic function, it is a function which evaluates and rank option during a search. It uses the problem specific knowledge to guide the process towards a solution efficiently. Then what is the meaning of this statement? First of all, heuristic function, which is denoted by h of n. N is the number of nodes. H stands for heuristic. So heuristic value of a particular node says that what is the approximate value for a particular node, or how much distance is required, or how much cost is required from the current node to the goal node. That value can be represented in the using heuristic function. So it can evaluates and the rank option during a search. And this heuristic value, it may not give the exact solution, at least it will give the approximate solution. It uses the specific knowledge to guide the search process towards a solution efficiently. So using this heuristic function, we can do the search process efficiently, because though it does not give any perfect solution, it can give the approximate solution from the current node to the goal node. Next one is the branching factor. What is the meaning of branching factor? It is a terminology which is used for each state in a search space. The branching factor refers to the average number of successors for each node in a search tree. It significantly influences the complexity of the search process. For example, the tree is like this. Suppose that this is the root node having 2 children, and this node is having suppose 3 children, and this node is having 2 children. Again, this node is having 2 children, this node is having 2 children, this node is having 2 children, this node does not have any child, and this node does not have any child. So if this is this kind of tree, then how we can say what is the branching factor? So branching factor says that what is the average number of children for a particular node. For this node, if you consider, there are 2 children. For this node, there are 3 children. For this node, there are 2 children. So on an average, everybody is having 2 children, but here it is 3 children. So this is called as the branching factor. So the branching factor refers to the average number of successors for each node in a search tree. And the complexity of the search tree and how much time it takes to search the complete search tree, that depends upon the branching factor of the node. Then the next term is search space. Search space encompasses all potential states and actions available during the problem solving. Efficiently navigating this space is key to finding solutions quickly. Again, the search tree or the search space. Search tree means where the tree which can be searched by the AI agent. Search space means the overall configuration of each state, including all the nodes and as well as the actions. Each node is called as a state, and the transition from one state to another state, that is called as the action. This is called as the action. So search space, which is a combination of all the states as well as the actions available while solving the game playing problem. And efficiently, why the search space is used, it will allow the user, or it will allow the AI agent or the machine to navigate efficiently, starting from the start node to the goal node to solve the complex problem. The next term is pruning. Especially already I have discussed in alpha beta pruning algorithm, which is used in game playing. It is this type of concept is used. So pruning means it eliminates the unpromising branches of a search tree to reduce the computational effort. It enhances the efficiency by focusing on potentially optimal path. So pruning means the branch which is unpromising, means even if you cut that branch also, which does not give any impact to take the final decision in the search space or for the search tree or for a game playing problem. So that type of branches or leaves can be pruned from the search tree. That terminology is called as pruning. Especially this pruning concept is used in game playing, that too in alpha beta pruning algorithm. So if the unnecessary branches or unnecessary leaves which does not have any impact to take the final decision will be pruned, then it can enhance the efficiency. That means it can reduces the time of search as well as it can reduces the cost of the search. So it reduces the computational cost as well as it enhances the efficiency also to find the optimal path. The next one is fuzzy logic. So fuzzy logic is actually, it is not a logic. It is a situation which can handle the situation which is like fuzzy. It is not like a Boolean logic. It is not a logic also. It is a concept which is used to handle the situation which is vague or which is uncertain or which is improbable or which is fuzzy in nature. Okay, so fuzzy logic is a form of logic that allows reasoning with uncertain and imprecise data. It models the real world scenarios by using degree of truth rather than strict true or false values. So as I told, this fuzzy logic in artificial intelligence, it can handle the uncertain situation, and each uncertain situation can be assigned with some values whose value ranges between 0 to 1. So it may be 0.1 or it may be 0.2 up to 0.9, and maximum it can 1, not beyond 1 or not less than 0. And these values are called as, these values are assigned based upon the degree of truthness at a particular moment of time. If I say the temperature is warm, the temperature is very warm, the temperature is extremely warm. So all the three terminologies are different from each other. Depending upon the context, depending upon the priority of the word, these values will be assigned by using some functions. Anyways, I'll discuss that. What is that function? That function is called as the membership function. So how these values are assigned? Based on these values are called as degree of truthness. So this is applicable for this particular moment of time. That is what is called as degree of truthness. So overall, I can say this fuzzy logic, it is not a logic. It is a concept in artificial intelligence which can handle the situation which is fuzzy or which is uncertain or which is vague or which is imprecise or like uncertain. Next terminology is crisp sets. So crisp sets are the classical sets in which an element either belongs to the set or does not. Membership is binary and represented by 1 or 0. 1 means if it belongs, 0 means does not belong. So compared to our fuzzy set or fuzzy logic, crisp logic is there, which is nothing but the Boolean logic. It consists of two values, either 0 or 1. Means this is absolute false, this is absolute false, and this is absolute true value. So if it is absolute false, then it is represented as 0. If it is absolute true value, it is represented as 1. So these two values are used in case of the crisp set. I like mango. I does not like mango. So the true value means I can represent, if the sentence is true, we can represent with 1. If sentence is false, we can represent with 0. So that is called as the crisp set. That is the normal set or normal logical theory which we used to use in our binary logic also. But if we use this crisp set, it will not be applicable in artificial intelligence, because artificial intelligence can handle how these uncertain situations can be handled by the AI machine. That is why fuzzy logic is needed. So most of the time we cannot use this crisp logic or the classical set or the Boolean logic. The next one is the fuzzy sets. Fuzzy sets generalize the crisp set by allowing the partial membership of elements. Membership is represented by a value between 0 and 1, indicating the degree of belonging. Just now I have discussed in fuzzy logic. Fuzzy sets is a generalization of the crisp set. In crisp set, the values are fixed, either 0 or 1. Whereas in case of the 0 or 1, whereas in case of the fuzzy set, the value ranges between 0, 1, means 0 0.1, 0 0.2, up to 0 0.9, then 1. So these values are called as the degree of truthness, and these degree of truthness are represented using some membership function. Anyways, different types of membership functions are there in fuzzy logic. Already I have discussed in my theory videos. You can watch my previous videos like the trapezoidal membership function, or triangular membership function, or sigmoid membership function. So using different type of membership function depending on the situation, the degree of truthness can be assigned between 0 to 1. The next terminology is membership function. A membership function defines how each element in the fuzzy set's universe is mapped to a membership degree. It quantifies the level of an element's inclusion in the set. Just now I discussed, this is a function based upon the degree of truthness. The value can be assigned between 0 to 1. Next, fuzzy rules. As it is a logic, so different types of rules are used inside the fuzzy logic. So fuzzy rules are the conditional statements in the form of if-then that guide the decision making. So these rules link input fuzzy sets to output fuzzy sets. So the rules or the protocols which are defined inside the fuzzy logic are in the form of if-then statement. Like for example, if I say if the outside temperature is 30 degree, then set the AC temperature to 16 degree. So like this type of decision making statements or the knowledge can be represented using if-then statement. So why these rules are used using if-then, which can guide for the decision making approach. Next one is the fuzzification. Fuzzification is a process of converting the crisp input to fuzzy sets. It enables the system to handle uncertainties in input data effectively. That means the process of converting the crisp set to fuzzy set. Crisp set which allows only two values, 0 and 1, whereas the fuzzy set allows the values between 0 and 1. So conversion of the crisp value to fuzzy value is called as fuzzification. The same reverse process of fuzzification is defuzzification, which converts the fuzzy output back to the crisp values. It provides a complete output for decision making or control action. Next, fuzzy hedges. Fuzzy hedges are the linguistic modifiers such as very or somewhat that refine the membership function. They adjust the degree of fuzziness in linguistic variable. So fuzzy hedges are nothing but the linguistic modifiers or the linguistic variables. That means the word which we use, the human being uses in our day-to-day life for uncertain situation. Those values or those words can be assigned. For those words, some value will be assigned using the membership function. Just now I have given one example while discussing the fuzzy logic. If I say the temperature is warm, the temperature is very warm, and the temperature is extremely warm. So all these are called as the linguistic variables, because these are normal language which we speak in English, but system does not understand or AI application does not understand. So to make the system understand, for these linguistic variables, some values are assigned by using some membership function based on their degree of truthness, whose values depends upon 0 to 1. And this membership function, how it assigns the value, different formulas are used. If it is a triangular membership function, the formula would be different. If it is a trapezoidal membership function, the formula would be different. And to assign the values for the, especially for the fuzzy edges, the membership functions are defined by the subject expert or the domain expert. It is not same like in every case. It varies from domain expert to domain expert. Okay, so these are called as the fuzzy edges, which are called as the linguistic modifiers or linguistic variables. Next one is the neurophagy systems. Neurophagy system combine the two technology. One is the neural network, another one is the phagy logic. To enhance the learning and reasoning, neural networks handle the adaptability while phagy logic manages the uncertainty. As I discussed, phagy logic or phagy system which can handle the uncertain situation. Then what is the need of neural network? That is why the terminology is called as neurophagy system. Actually, the neural network, it is a concept or it is an algorithm which is used in machine learning algorithm. It has the capability, it has the self-learning capability as well as self-adaptability capability. Means from the data it can learn what is the pattern of data, even irrespective of any situation, it can adaptable to that situation also. So because of this self-learning and self-reasoning capability, this if we add the neural network system to the phagy logic, definitely the outcome can be efficiently increases. So that is why neurophagy systems are more advanced concept in the case of phagy logic. Then phagy clustering. Phagy clustering, the name itself, first of all, phagy means uncertain. It combines the uncertain situations or uncertain values to a cluster or to a group based upon their similarities and dissimilarities. That is why the name is called as phagy clustering. So phagy clustering groups the data points based on the membership degree rather than the strict assignment. So each point can belong to multiple clusters to varying extent. That means what? Suppose as I discussed before, the phagy logic which assign the values between 0 to 1, maybe 0.1, 0.2 up to 0.9 and till 1, and the value should not beyond 1 or it should not be less than 0. Suppose we have 1 lakh values and all the membership values are assigned to all the linguistic variables or all the situations in between 0 and 1. But how many values are similar? Like the points, the data points or the values which ranges between 0 to 0.1, that we can make it as one cluster. Then from 0.1 to 0.2, all the values we can make it into another group. So that is called as the phagy clustering for better decision making for the phagy logic system. So this is all about for this particular module 3. I have discussed so many terms related to game playing in artificial intelligence as well as phagy logic, all the definitions and terminologies. I hope you might have understood and enjoyed. And to prepare the preparation of this video, I have referred this Aeronautical book for artificial intelligence. For your reference, I kept the picture of this book. Even it is available in Amazon also. I have given the link. You can purchase it. In my next video lecture, I will discuss few definitions and terminology for the next chapter. That is our 4th module. So thank you.
Like, share and subscribe. Hit the bell icon for more updates.